85 Math and Science. Hello everybody, I'm teacher Tenny and here today I'm going to talk about the secondary 3 chemistry qualitative analysis, a topic that many students have problem with. Alright, I'm sure everybody has seen this table. But the problem is, how are we going to remember this table? Alright, uh, yes, we have issue. It's not an easy thing to remember, but there's one way that you can do it, and that is to remember it by groups. So what do I mean? Alright, so first is the more obvious colors. Copper, when you add sodium hydroxide or aqueous ammonia. Take note, these two are ways for us to check what cations are present in that particular solution. So if we add any of these, take note, this is blue. So when you see blue color, normally is copper related. Okay, iron is green. Iron 2, now iron 3 is reddish brown. So the soluble or insoluble excess we'll leave it later. But for now, remember it by colors first. Copper, blue, iron 2, green, iron 3, reddish brown. Calcium, zinc, aluminium, lead, they are all white colors. Okay, then now you'll be asking, so if all of them is white, how are we going to differentiate? So there are some quite obvious differences. So number one, the one that I always remember is zinc, all soluble in excess. Okay, zinc both is soluble in excess. Then for calcium, we have no PPT for aqueous ammonia. No PPT for aqueous ammonia. So remember all these obvious differences, then it's easy for you. However, for aluminium and lead, okay, both of them have the same reaction, whether in aqueous ammonia or sodium hydroxide. Then how are you going to differentiate it? Okay, for these two, then normally we will add things like hydrochloric acid to it. Okay, so if you add acid to it, lead chloride is insoluble, then you see a insoluble PPT. But if you add hydrochloric acid to aluminium, then you won't see any PPT. So that would help you to differentiate between the two. However, I think for now, the first step that we can slowly grasp is remember that zinc is soluble in both. Calcium has no PPT in aqueous ammonia, then it'll be easier for you. Okay, so then in this way, then not so much problem. Okay, for ammonium, you realize that ammonia gas is produced upon warming. So note the key terms: warming, ammonia with sodium hydroxide. Then you know that there's the presence of ammonium. Okay, so take note of these major differences. Copper blue, iron 2 green, iron 3 brown, the rest is white. Okay, with zinc soluble in both. Calcium has no PPT in aqueous ammonia. Okay, so remember this basic one first, then you should be able to answer at least 75% of the question. All right, then we take a look at this is the anions. So just now what we seen is cations, now is anions. So anions, take note of the keywords again. Okay, keywords are, so if you are testing for nitrate, you would see words like aluminium foil. So once you see aluminium foil, you see the presence of nitrates. Okay, if you are testing for carbonate, you will see carbon dioxide. Okay, so the term carbon dioxide would appear in the question. If you are testing for chloride, you most probably will see silver nitrate, and then it's white PPT. Okay, so take note of the key terms. Iodide, also silver nitrate, but it is yellow PPT. Sulfate, barium nitrate, white PPT. So nitrate, you see aluminium. Carbonate, you see carbon dioxide. Chloride is silver nitrate. Iodide, also silver nitrate, differentiated by colors. One is white, one is yellow. Sulfate, you will see barium. Okay, so once you see barium, you know got sulfate. Once you see carbon dioxide, you know got carbonate. Once you see aluminium foil, you know there's nitrate. So these are certain keywords that you see, then you will be able to solve. All right, so let's continue. Okay, then certain things like the solubility you need to remember. Sparse salts are soluble, all nitrates are soluble. Then we see these five here. Okay, normally I like to remember in this way. A, B, C, and then later PB. So these are the more commonly tested insoluble salts. So you see this is Cl, Cl2, the rest is SO4s. So I remember in this way, I first write A, B, C, PB, then PB, and then later Cl, Cl2, and the rest is SO4s. So that helped me to remember which are the insoluble salts that are more commonly tested. For carbonates, only the spar carbonates are soluble. For hydroxide, only the spar and calcium hydroxide are soluble. So with this, you can remember uh, almost like I say 80% of it. So there are some still, but these are the more commonly tested ones. All right. Okay, let's look at the. So for this particular topic, we normally have it in the uh, flow chart form. So same thing, we try to take note of all the keywords. Okay, so keywords, what do we have? So for example, they add acid. Okay, then we find things like that. Okay, strong heating is white color. So if it's white color, I would be more on the side of zinc, aluminium, lead, calcium. Okay, then you see this is aqueous sodium hydroxide, insoluble. So just now we remember zinc is soluble in both, so definitely this is not zinc. Okay, this is not zinc. Okay, so the probability would be things like calcium, aluminium, or lead, either one of it. Okay, but they add hydrochloric acid, so it wouldn't be lead. Okay, it would not be lead. Okay, and then there's a colorless gas here produced. So it's a solid, add acid, you get something uh, a solution with a gas. So what gas can this be? So we learn something. If we add acid, probably will be carbon dioxide. Okay, the probability is carbon dioxide. Then we continue to see what we may have. Okay, so these two gases are the same. All right, these two gases are the same. So what gas can this be? Because just now, if you remember, to test for chlorides, okay, to test for carbonates, we add the acid. Okay, we add acid. Hence, this would be carbon dioxide. So both of these gases are the same. Okay, then like I say, to test for carbonates, we add hydrochloric acid. So which means this one must be something carbonate. But what carbonate later we will see Okay, but so it is between calcium and aluminium. Okay, calcium and aluminium, but this is insoluble in excess aqueous sodium hydroxide. So if you can remember, if it's insoluble, it has to be calcium. Therefore, aluminium is not in the picture. As such, this is calcium carbonate. Okay, then you have carbon dioxide. Then if you upon strong heating, this is thermal decomposition. You are left with calcium oxide. Okay, then you add water. This is calcium hydroxide. Okay, this is calcium hydroxide. Then over here, calcium carbonate plus hydrochloric acid, then you get calcium chloride. So in this way, we would have guessed everything that we need. Okay, the next thing that you need to know, when you add sodium hydroxide, all the PPT here will be something hydroxide. So because this is calcium, this is the cation calcium, this would be calcium hydroxide. Okay, so anything that is the you add anything sodium hydroxide, in the end the PPT form will be whatever hydroxide. All right, so this is how we do such question. Okay, let's do more examples. So again, this is something that's white in color. Then you see we have keywords silver, and then it's white color. So if you remember just now we said if it's silver, you think of chloride. So the PPT name here will definitely be silver chloride. To have chloride here means you would have chloride before that. Okay, you would have chloride before that. So what chloride has does it have? Okay, if you are adding calcium hydroxide, this is a test. This is actually your lime water. If it's a lime water test, okay, if it is a lime water test, means before that got carbonate lah. Okay, lime water test is test for carbon dioxide. So this is your carbon dioxide. Okay, and then after you add this, then this one is your calcium carbonate. Okay, because you react hydroxide, then you get calcium carbonate. All right, so this one is carbon dioxide. What is this yellow thing that I don't know? We got to continue and see. But we can see that this is a white PBT. This time it dissolves in excess when you add to aqueous ammonia. So the one that can dissolve in both is zinc. So that's why this has to be zinc. Okay, aqueous ammonia means is ammonium hydroxide. So when you add, if you add excess aqueous ammonia and it dissolves in both, this has to be zinc already, zinc something. But because they already say it's test with silver nitrate, this is zinc chloride, because inside got chloride lor. Okay, zinc chloride. Then over here must be zinc something lah, because we say this is this is carbonate, right? So zinc carbonate lor. Okay, so if zinc carbonate, carbon dioxide come up, this one is zinc oxide. Okay, then just now we say whether you add aqueous ammonia or sodium hydroxide, in the end the PPT name will always be something hydroxide, hence this is zinc hydroxide. Okay, so that's how we do the question. Find the keywords, then you know what that particular item is, then you know what they have before and after that. Okay, let's continue. So now again we have a metal, got pop sound. Pop sound means this is hydrogen gas. Okay, hydrogen gas. Then we add aqueous ammonia. Again, this one is white PPT and is insoluble. So the one that's insoluble has to be either aluminium or lead. Okay, so hydrogen, then you say add barium. Barium is test for sulfate, so which means this one has to be sulfuric acid. Okay, then in the end the PPT name will be barium sulfate. Okay, then over here after you add acid, then they say it is a colorless solution. So if it's sulfuric acid, right, it cannot be lead because lead sulfate is insoluble. Hence, this one has to be aluminium. Okay, aluminium aluminium hydroxide for this Y hydroxide. Okay, which means this one has to be aluminium sulfate, because after you add the sulfuric acid, this aluminium sulfate. And to have aluminium here means you must have aluminium here lor. Okay, in this way you would have guessed whatever you need to guess. Alright, they like to test the white color because there's so many whites to remember lah. So therefore you need to make sure that you know all the different white colors, then you'll be quite alright already. Alright, this is the end of the part for qualitative analysis. So there's more to go. Let's stay tuned.